Hi, I'm Bob Rumer and I teach physics and bioengineering here at California Lutheran University. In this short video, I'll show you how our new 3D printer works. I'll design, print, post-process, and use a three-dimensional module that is a track of a more complicated marble machine. This would be an example of how our students might use the 3D printer in an introductory to engineering class. So let's get started. Here I am designing a small module for a marble machine using SolidWorks, a three-dimensional computer-aided design program. This easy-to-use and inexpensive software allows students to quickly design 3D objects limited only by their imagination and skill. After designing the part, it's loaded into a program which controls the printer. Here I'm loading my model along with 3 other parts which will be processed together. With a couple of clicks of the mouse, the parts are sent to the printer. So how does it work? You are viewing a high-speed replay of an 1.5-hour print job. A thin layer of plastic powder is spread across the print area. Then an image of the lowest layer of the model is printed onto the powder in exactly the same way that an inkjet printer works. But the ink has been replaced by a specially designed binding liquid. When done with the layer, the plate is lowered less than a millimeter and the process is repeated. Your model is built up vertically, layer by layer. When the printer is done with your model, it's buried in powder, so you must vacuum up the unused powder to uncover your model. The parts have the consistency of damp chalk and are very brittle, so you have to be very careful not to break them. This can be tedious for complicated models with small features. So how long does all this take? Printing is about 1 hour for each inch of height in your model. Then as the parts are baked for about an hour to remove moisture. Vacuuming generally takes 5 to 10 minutes. In the next segment, you'll see us remove the dust, which can take actually several hours on complicated parts. All in all, it can be a long and difficult process, but the results are worth it. The powder tends to stick to your model, so you have to brush it off carefully. As you remove the dust, colors and fine details emerge. Because the model is so brittle, great care must be taken during dust removal. It can be quite a challenge. The machine also has an airbrush for finer work. Each student designs and builds their own module, but then as a class they have to design the overall machine and make sure each part will work properly with adjacent parts. The final step for your model is to coat it with an infiltrate, which strengthens the model and makes the colors vibrant. The infiltrate is a clear liquid cyanoacrylate compound, sort of like an epoxy. It absorbs into the model a few millimeters and hardens as it dries. There are 3 types of infiltrate available, which allow you to trade off cost and drying time for durability. The most expensive infiltrate absorbs 5 millimeters into the model and allows you to build functional models for mechanical parts such as gears and levers. In fact, you are able to even cut screw threads into these types of parts. After the coating is complete, the parts need to dry. This can take anywhere from 5 minutes for the cheapest infiltrate to overnight for the most durable. As you can see, the printer colors the parts as they're printed. With over 300,000 colors and a resolution of 600 dots per inch, they say you can even print photographs on surfaces. Once done, the parts look beautiful. For this particular project, the modules are mounted with nuts and bolts to a vertical pegboard. This is just one of many modules making up a complicated marble machine where steel balls roll down through all sorts of crazy tracks. This is a great project for our freshman engineering students, many of whom have never built anything or ever used common tools.